Okay, we're going to wrap up section 6.2, and this will be the last of all the videos with an application. So same idea as in the last section where you read a problem and look for a couple of equations. Here we're going to read through the problem that's printed here, and we're going to look for 3 equations in here. So let's do that first. So I've already listed what the 3 equations will be. I've pre-read it, but let's look at this. A collector paid $7 million for 3 paintings. So that's going to be here. Paid $7 million for 3 paintings. So I need to make an equation out of that. I'm going to need 3 variables. X, Y, Z is fine. What I'm going to do is I'm going to use M for Monet, P for Picasso, and V for Van Gogh as my variables. So that means Monet plus the Picasso plus the Van Gogh totaled or equaled 7 million. Okay, let's keep reading and we'll get to this point. The Monet was 800,000 more than the Picasso. So Monet was 800,000 more than Picasso. So that's M equals 800,000 plus more than. And then again, remember I want MPV, MPV, MPV like that. So I want to solve this and put it in the correct order. Okay. Let's go on to the last one. Van Gogh cost 2,000 more than twice the Monet. So that's Van Gogh V cost 200,000 more than twice the Monet. So again, this is equal, this is more than, twice means times 2. So we can see what we've got here. V equals 200,000 plus twice M. Again, I want MVP, so I need to solve this. So let's move the M over here. So here's my 3 equations here. That one, and that one. So let's go ahead and write our matrix here, or our system. Equation number 1. Equation number 2, we're going to use this. And finally, equation number 3, we're using this one. And I'm going to kind of keep things in columns here. Makes it a little nicer. Okay, so we've read the problem, pulled out the language for each of the equations, and then went from words to math equations. And then finally solved them in an order where we have MPV, MPV, MPV. What you're going to notice here is that this particular system is missing variables. So we haven't seen that before. But when you start looking at this, if I want to get rid of variables, if I put these two together, I might get rid of the m. I'm going to pick up a v here. If I put these two together, maybe I get rid of the m, pick up a v there. It's kind of odd. This equation here, we want to leave it there and we want to use it. So what we want to eventually get down here is a p and a v as we solve. So what we would like here is a p and a v, and then eventually a v here, so that we have that structure, and you have numbers over here. That, remember, this is the goal of 3 equations, 3 unknowns, so that when you finally get something here, you put it in here and get p, put these two in here and get m. So we want to get rid of m's. So let's start with these two. Let's take the first one, multiply it by a negative, and then add it to the second one, and we'll get a new second equation here. So we got rid of the m's. I got minus 2p, and I got this minus v here, and here I have a minus 62,000. No, I'm sorry, yeah. 7 minus 8, okay. Okay. Now, I'm going to go ahead and make these all positives. You can do whatever you want with the equation. So for my final second equation, let me rewrite this over here. Here's our original. So we want to keep that. And then I multiplied by minus 1, added it to this, got this. I'm going to go ahead and change all the signs, or multiply through by minus 1. So my new second equation now okay, and then my third equation's still here. Also want to get rid of this m, okay, which means I also got to use this equation. This isn't going to help. If I try to add these two, I'm going to wind up with an m and a p. I'm not getting where I need to be. So again, let's use that first equation to get rid of any m's. So this time I'm going to multiply this by 2 and add it to this. So I'll have 2m minus 2m. So let's multiply the top one by 2. And let's add it to this bottom one. So if I add these up, I get 2p plus 3v equals 14,200,000. So that's my new third equation. So let's go ahead and rewrite our system here. So there's our original first. There's our new second that we just had figured out. And then finally, here's our new third equation. Okay, so I got rid of the m's, and now I need to get rid of the p here so that I have just v's down here. Well, that's easy. These are the same, so why don't I multiply this by a negative and then add it to the bottom one. So I got minus 2p minus v equals negative 6,200,000. And then add it to the bottom one to make a new third equation. All right, so if I add these up, the p's cancel. 3 minus 1 is 2. So I got 2v equals, and this becomes 8 million. And then finally, if I divide both sides by 2, v equals 4 million. So our final system starts looking like this. And finally, v equals 4 million. So that's what we were trying to get to. All 3 variables, 2 variables, 1. So now I can start subbing in, going up. So I know v equals 4 million. I know what they paid for the Van Gogh. What did they pay for the Picasso? Put v in here, solve for p. Okay, subtract 4 million from both sides. Divide both sides by 2, so the Picasso costs 1,100,000. Finally, now that I know what p and v are, go up 1, substitute them into the first equation, solve for m. M equals P and V. Oops. Yeah. M plus P plus V equals 7 million. Getting a little cramped here. Okay, if I figure all this out, add these together, subtract it from 11 million, then M will equal, you can figure it out, 1,900,000. And that's it. So basically it looked a little strange, but the bottom line is get rid of one of the variables all the way down. Even if in this case we introduced a V when we did it, that's fine. You're just trying to get rid of all the m's below. That should leave you with 2 equations, 2 unknowns, and then just get rid of one of the unknowns, adding the second 2 together. And that's it.